In this video, we're going to walk through a quick example about how to do a hypothesis test for our paired differences method. So we already went through the actual formula for this, and it's basically the same formula that we've used for x bar, but with some very slight changes in how we actually calculate our test statistic and how we state our null and alternative hypothesis. So for this one, we're going to do a hypothesis test using alpha is equal to 0.05, and we're going to do a two-tailed test. We're going to say h naught is equal to our mu d is equal to d naught, and our alternative, or HA, is mu d does not equal d naught. So if we turn that into our hypothesis test value, or our t sub alpha over 2, we get t of alpha over 2 with 7 minus 1, or 6 degrees of freedom, is equal to our t sub alpha over 2 value of 2.447. Now we just need to calculate our test statistic. So our test statistic is going to be t is equal to our d bar minus our d naught over our sigma d over square root of nd. Since we don't have sigma d, we're going to substitute in our s. So we get this is equal to d bar minus d naught over our sd over square root of nd. We plug in those values, so we get d bar is equal to 2 minus our d naught, and our d naught we're going to set equal to 0, so minus 0 over sd, which is 0.8165, divided by the square root of nd, or the square root of 7. So we're going to get 2 over 0.8165 over the square root of 7, 2.645, so we get 2.645, and that turns into 2 over our 0.3086, which equals 6.481. So if we compare that 6.481 to our 2.447, we see that that is much larger. So we get our t value, t is equal to 6.481, which is much larger than 2.447, which is our t sub alpha over 2 value. So that means that we can successfully reject. So we reject h naught and accept HA. So if we look at this, this is a different result than our motivation video, where we did this same value and we failed to reject and say that x1 is different than x2, or x1 bar is different than x2 bar, or mu1 is different than mu2. And using this new method where we can compare the two differences individually and then look at their total variation, we change our test and successfully reject h naught and accept HA.